Traditionally, most institutions have had databases that were largely centralized. In their pure form, centralized databases held information at one specific point. And in order to interact with that information, you'd only be able to do so if you could access the central power. Now, there's a good logic in centralization. It can reduce the risk of data being accessed by third parties, assuming the controls around the central point are good. Secondly, companies can enjoy economies of scale in running a centralized computer system and a centralized network. It can also enable better processing speeds and responsiveness, amongst other things. Now, to mitigate the risk of having a single database going down or systems redundancy and the paralyzing impact on business operations, sometimes companies simply constructed decentralized databases. Simply put, they built a few backups as a precaution in the event that the main database went down. Blockchain turns this entire architecture upside down. The database on a blockchain is distributed extensively amongst multiple users. Rather than the database being stored at a central point, a blockchain database can be distributed to millions and an unlimited number of users. The Bitcoin blockchain is an example of this. If you are a participant on the Bitcoin blockchain, you can store the entire database on your own hardware. Your own record of the database will be updated together with other people's copies as transactions are executed on that blockchain. The emphasis here is that multiple users have access to the database. It enhances transparency, integrity, and the ultimate security of the blockchain. This is a very, very important characteristic, a distributed database. Now, a distributed database goes against our natural instinct when it comes to security of the database and the information contained. I'm going to address that shortly when I talk about cryptography and how this ensures the integrity of the blockchain database.